recording. All right, so we are recording right now. This is in the announcement. So, as I said, please, use this long weekend because, this is Wednesday and we are meeting on Monday again. So you have what, 4 days, 5 days ish, to work on this. So I would recommend everybody to download this, just work on it. And you don't have to take it as if it is a real exam. Use the book, use the material, use your notes, okay? And if you figure that you cannot answer some of these questions, try to figure out why you cannot answer those questions. Or if you figure out that, hey, in order to answer this question, I need to know about blah, 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 and I might not be able to remember blah, 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 then you'll kind of put it in your notes. It is open book and open notes. So you know ahead of time, it is open book and open notes. There's no quantity requirement. In other words, if you want to bring in like a whole huge pile of books and paper and whatnot, you're welcome to. I mean, this is the entire class. Okay, we got space and room in this classroom. Unlike when we were, was it Rave Hall when you took 310? Yeah, Rave Hall is not a good place to take exam because yes, you guys are all shaking your head. It's like you cannot even put a letter-sized piece of paper on that surface. Yep, it's horrible. So, but this classroom does have a lot of space, so you'll do it, plan accordingly. Okay, plan accordingly. Um, the scope of the first exam is going to only include and up to the topic before relation. So relation is not a part of the first exam. So that means we have covered all the material already, even before this Monday. Okay, so we'll be up to and including Cantor's mapping function, and that would be the last topic for exam one. Relations will be going to the second exam, exam two. All right, so are there any questions about exam one? So your actual exam date is the Monday after next Monday or 1 week after next Monday, and we'll talk about this practice exam on Monday. Are we good? All right. So I got a few things. One is using ChatGPT. So here's, excuse me. So this is what I asked ChatGPT or the TA to do. Generate questions to help me confirm my understanding of the properties of relations. So this is just an example, okay? If you are going like, yeah, but relation is not even in exam one. Why do I care? Well, I mean, I'm just showing you what you can do with the TA, the teaching assistant. So you can ask it about quantifiers, you can ask it about the set operators, you can ask it about injection, surjection, and so on. Okay, but we're gonna work this out because since I have it here already, we're gonna work out some of the questions here. So for the questions, the first one is reflexive check. Suppose X is the set of 1, 2, and 3, and R is the set that has 1, 1, 2, 2 in it. The question is R reflexive on X, Y, or Y not? Okay, what do you think? It is not, okay, but why is it not? How would you explain that? Because 3 does not relate to 3. Very good. Okay, so that's exactly what we'll have to write as the answer. So we say, R is not reflexive. And I'm going to use, LaTeX to specify the fact that 3, 3 as a two tuple in R is false. Okay, so let me get rid of this. Escape. Come on. There we go. Okay, so that's for question number one. And we are working on question number two, symmetric check. Assume X is AB and R is AB, which in the tuple, it's R symmetric. And if it is not symmetric, what would be needed to be added for symmetry? Okay, so how do we answer that question? R is not symmetric. Okay, we need to add which element? Hmm? Just switch? What? What? No, no, we're on question number two. Question number one does not ask about symmetry. Okay, so what do we need to do? Add BA. Yep, you add BA as a two tuple to R so that it becomes symmetric. Okay. All right, let's move on to question number three. Transitive. Suppose R is 1, 2, 2, 3, 1, 3 over X, which has elements 1, 2, and 3. Is this R transitive? Yep, it is. Okay, so R is transitive because for every way to choose E, F, G in X, we can confirm that. Okay, this is really annoying. This is coming from uh, Grammarly. So Grammarly wants to pop up and fix my grammar all the time, even when I'm just typing equations. Okay, so what needs to be true for every way to choose E, F, G in X in order for R to be transitive? Hmm? So we is an implication, right? Is an implication. So we can say that E, R, F, and F, R, G implies, which is right arrow, right arrow, E, R, G is true. Okay. So we have to go back to the definitions. Okay. In other words, I would not try to use the semantic or use the words to imply what needs to be done or what needs to be true. I would go all the way back to the quantified expressions. Okay, because that is how each one of these quality is defined. All right, so get rid of this again. All right, so we are moving on to question number four. Okay, so let's go to number four. So number four is asking, suppose R is ABBA over X, which only has AB in it. Is R anti-symmetric? If yeah, why or why not? So what is the answer? The first question, the first answer is whether it is or is not anti-symmetric. Okay, so what is the definition of anti-symmetry? Yep. Okay, so there's an equality that is being implied. So we can say this one. So is it anti-symmetric or not? It is not anti-symmetric. It is not symmetric because when E equals to A, okay, we can do it the other way around too. F equals to B, then the actual statement that needs to be true is not true anymore. But I will state it too. So then um, E, R, F, and F, R, E, the whole thing implies E equals to F is false. Okay, so let me once again get this out of the way, but it's kind of annoying that it keeps popping up. Okay, so do we understand the answer to question number four? First of all, it is not anti-symmetric. The reason why it is not anti-symmetric is when we choose E to be A, F to be B, then the expression that needs to be universally quantified to be true is now false because ERF is true because AB is in R. FRE is also true because BA is also in R. However, A and B are not the same. So that means A equals to B or equals to F is false. Then we have true implies false, which means the implication itself is false. So if we can find one counter example to make that expression false, then universally quantified expression is false. So be good with that? All right. All right. So the next one is something that we haven't really talked about, but I'm going to use this as an opportunity to talk about. Oh, this is actually something that we might have talked about. Equivalence relation. Consider the relation has the same remainder when divided by 3 over integers. Which three properties does it satisfy and why? Okay, so this is something that we haven't talked about. Um, so what it is asking is actually um, what we also what we also call congruent modulo 3 in this case. So we have at least two people in this class that should remember that from CISP 310. So congruent modulo 3 is stating exactly that. So you have two integers, okay? Those two integers are considered to be congruent modulo 3 when you say, okay, what about A mod 3? What about B mod 3? If the results are the same, they have the same remainder, then they are considered to be quote unquote equivalent in this case, also known as congruent modulo 3 in this case. The question is not even so much asking about what is congruent modulo 3. It is asking, is that relation, what properties apply to that particular relation? Okay, so a few examples can be helpful. I'm going to use the whiteboard for that example. So the first thing is, well, let's pick 4, 1, and 4. Okay, this is the way I would write, congruent modulo 3. 1 and 4 are congruent modulo 3 because 1 mod 3 is 1, and 4 mod 3 is also 1. So they are congruent modulo 3. Okay, I can pick something that are not. Okay, so 2 versus 13. Okay, these two are not. Okay, this is false. This one is true. Okay, because 2 mod 3 is a 2, 13 mod 3 is a 1, so they are not the same. They are not congruent modulo 3. So the question is asking, given this is the relation, which means this particular R is going to have, I can give you some examples. 0, 3 will be in it, okay? 1, 4 is going to be in it. 2, 13 would not be in it. 2, 17 is in it, and so on. So is that okay? Does everybody understand what two tuples would be in this particular relation? Okay. Yep. Mm, well, this is just the way I express congruent modulo 3. The mod operator cannot really directly be used as the relation because what we are saying here is A is congruent modulo 3 with B if and only if A mod 3 is the same as B mod 3. So in this case, you can use the mod operator in order to define what congruent modulo 3 means. Yep. All right. So what else is in the set? What about 0, 0? Do you think 0, 0 should be in the set? Well, ask the question. By definition, is 0 mod 3 the same as 0 mod 3? I think that should be fairly obvious. Yes? Okay. All right. So we put 0, 0 in here and so on. All right. So I think right away we can identify one of the three properties that is true. It is reflexive. Every integer is is congruent modulo 3 with itself. Yes? Okay. So we'll write down the answer. Okay. So we're gonna say um which three properties? Okay. It is reflexive. Okay, reflexive. Okay. What else? Do you think it is transitive? A is congruent modulo 3 and with B, B is congruent modulo 3 with C. Does that imply A and C are also congruent modulo 3? Yep. If you say no, you have to give me an example. Hmm? There's no C? I'm not sure what you mean by there's no C. So if A and B are congruent modulo 3, and B and C are also congruent modulo 3, does that imply A and C are also congruent modulo 3? That is what I'm asking. So you need to remember the definition of transitive, okay? Because that's what we are asking is whether it is transitive or not, okay? So where did we define transitive? The property of transitive, the quantified expression that tells us whether a relation is transitive or not. Okay, you don't have to answer that question, but you should know the answer. Okay, which module do we talk about this? Where in the module? And hopefully it is in your own notes because you're finding a definition that I wrote in my module is going to be a little bit more difficult than you looking up your own notes where you put all the definitions at the same place. All right, but the answer is yes, it is transitive. Okay, so it is transitive. So we just have to pick one more. Okay, do you think it is antisymmetric? It is not antisymmetric because you have to ask the question. Okay, we have some examples here. 0 and 3 are congruent modulo 3. So now the question is, if I flip the 0 and the 3, is that also true? Is 3 also congruent modulo 3? It is, right? So that means 0, 3 is in the relation. 3, 0 is also in the relation. And right away, we can tell that it is not antisymmetric. So it is not antisymmetric. Hmm? We can say it is not antisymmetric if we can find a pair of two tuples where they have the same values, but they are different and they are just arranged in opposite order between those two tuples. You just need one instance of that to disqualify the entire relation as being antisymmetric. All right, so we know it is reflexive. We got one. We know it's transitive. We got the second one. We know it's not antisymmetric. So what else can we even consider? Symmetry, exactly. So is it symmetric? I think we just worked out an example that clearly shows that it is symmetric. Yep. So now we say it is symmetric. Okay, so we just write down symmetric. There we go. So that's the answer to question number 5. Number 6. Okay, this is something that we haven't really talked about is partial ordering. So partial ordering is really just saying that, okay, a relation is a partial order when, if and only if, it is reflexive, it is transitive, and also antisymmetric. So those three are needed in order for a relation to also be called partial order or partially ordered. Yes, you have a question? Well, there are an infinite number of two tuples in here, right? So I can say, okay, do you think 3 and 6 are congruent modulo 3? Yes, because they're both, when you 3 mod 3 is a 0, 6 mod 3 is also a 0, right? So now I'm asking you, is 0, 6, is that in the relation? 0 mod 3 is a 0, 6 mod 3 is also a 0. So does this help convince you that congruent modulo 3 is transitive. 0, 3 is here. 3, 6 is here. 0, 6 is also here. Mm, okay, so if you use EFG, then you can say this is our E, this is our F, this is our F, this is our G. So you can do it that way. But there's no three tuple called EFG. We only deal with two tuples, two things at a time. Okay. All right. So getting back to question number 6, it is asking about less than or equal to as a relation on integers. So that means we are really just looking at less than or equal to. So the first thing is it reflexive? Is every integer less than or equal to itself? If you need to think about this, you're not listening to me carefully because I said, is every integer less than or equal to itself? What do you think? It is. Okay, so it is reflexive. The second one is it has to be transitive. Okay, so that means if I ask you if A is less than or equal to 2, if A is less than or equal to B, and B is less than or equal to C, does that imply A is less than or equal to C? Does the, yep. And how do we intuitively know that that is true? You use the number line, right? You use the number line. You go like, okay, A is somewhere here, B is somewhere here, and C has to be somewhere here. Does that mean A is not on the right-hand side of C? Yep. Yes. Huh? So it is transitive. We have okay. What do you mean by the same? Sort of. Okay. So equality is transitive too. Yes. So if that is what you're asking, the answer is yes. So if your relation is equivalence or equality, then that relation is also transitive. Yep. Okay. Okay. So the third property that we also need to confirm is anti-symmetry. In other words, if I have A is confirmed to be less than or equal to B, and B is also confirmed to be less than or equal to A, does that imply A and B are the same? Okay, let me write it out. We confirm that A is less than or equal to B. This is known to be true. B is less than or equal to A is also confirmed to be true. Does that imply A and B are the same? Question mark. What do you think? It has to be true. It has to be true because otherwise, yeah, this has to be true simply because of the way we define less than or equal to, right? So that means less than or equal to as a relation on integers satisfy all of these requirements, and the result, as a result, it is partially ordered. Okay, so we'll say it is partially ordered. Okay, so we'll say less than or equal to is a partial order. Okay, in fact, it is a total order, but since the question only asks about partial order, we'll just say it is a partial order. And it is also asking why it is not symmetric. That's not too hard to figure out. We can say it is not symmetric because um, it's not symmetric because it is not always the case. Okay, so we can say 1, 3 is in the relation, but not 3, 1. Okay, that's all we need. We need one counter example to show that it is not symmetry. Okay, so I think that's number 6. So now we have all of these answered. Press the enter key, and we'll see whether, okay, It's not supposed to say nice work because I actually turned off all the uh, features to make it sound nice to me. Um, in fact, if you look at my setting, it is bare bone and with no social buffering. I did not even know there's such a term called social buffering, which is, to say the minimum thing to make the other person, feel comfortable. I intentionally wanted to turn it off, and apparently I could not turn off some of the really kind of basic features. Okay, but let me see. Okay, let's check whether our answers are correct or not. Okay, for question number one, it is correct. Note, always check every element, not just one. Okay, so it actually remind me, you know, okay, in this case, 3 3 is not in R. That's the reason why, the R, the relation is not reflexive, but it's also reminding me that, okay, remember to check everything. To fix, add the missing mirror pairs. Okay, well, that's not a bad way to describe it. This is correct, 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 correct. I nailed the essentials. To deepen your understanding, let me challenge you with one trickier reflection question. Can a relation be both symmetric and anti-symmetric? If yes, give an example. If not, explain why not. What do you think? We have answered this question already on Monday. Check your notes. Hmm? Mm, that's one way to have a relation that is both symmetric and anti-symmetric. So if you look at equivalence or equal to, then it is both, right? A equals to B and B equals to C implies A equals to C. It is transitive. A equals to B and B equals to A implies A and B are the same. Wait, it is equal to begin with. Okay, so that's a trivial case, but it is also that's also symmetry and also anti-symmetry at the same time because A equals B means B equals A. They have to be both in the relation. Hmm? Say again. It is an example, but it's not the simplest example. What was the simplest example that was both symmetric and anti-symmetric? Yes, the empty relation. Yes. So the empty relation is both symmetric and anti-symmetric at the same time, but there's one more. It is also transitive. The empty relation is also transitive. Cool. Okay, so let's put in that answer and see how ChatGPT is going to grade our answer. It's probably going to go like, "Well done. This is cool." We'll see. All right. So to answer this question is an empty relation R equals to the empty set is always symmetric and anti-symmetric regardless of the set X or whatever set is defined over, regardless of the set that the relation is defined over. All right, let's see what kind of wow. It's not just exactly, it gave me a little bullseye with an arrow or dart. That is social buffering right there. Great observation, and so on and so forth. And it even used my definitions of what is anti-symmetry and also what I mean by symmetric. All right. So why do you think I showed you ChatGPT with all of these questions? Exactly. Yep. As somebody said in, ratemyprofessors.com, getting an A in text class is hard, but failing is harder, with especially this class. Yep. Hmm? Because there are all of these tools to help you. Now, it is kind of abstract, but with these tools, and if you spend the time to really try to understand the material, because you can give it the wrong answer, and it will tell you why it is wrong. Okay, it will actually diagnose why you got it wrong in the first place. It will give you some ideas of, okay, I think you might be misunderstanding this, or you might be confusing these two things, and it will give you a clarification, to make sure that you can differentiate between the cases. Do you guys want to see how we can diagnose problems? Like intentionally, I can intentionally give it a wrong answer, and you guys can observe how ChatGPT can say, okay, you didn't quite get right, but I think I know why you got it wrong in the first place. So let's do that. Okay. So give me some more questions, but this time about functions, injection, surjection, and bijection. Okay, so this time it does relate to your exam one. Okay, so come on, give me something. Give me something cool. All right, so it doesn't, it even gives you some, description of what each one is about. So now we have the actual questions. So I will say I'm going to answer one question at a time. Okay, so I will say I will answer just quill one for now. Okay, so what is it asking? So it's asking f is 1, 2, 2, 3, 2, 4. The supposed the domain, intended domain is 1, 2, and the codomain is 2, 3, 4, and it's asking is f a function, why and why not. So I'm going to give you the wrong answer. Okay, so I'll say yes, it is a function, which it is not, and I'm going to give it an answer. Okay, I'll even explain why that is the case. So I'm going to say both 1 and 2 from the domain maps to something in the codomain. So what I missed, okay, in terms of concept, is I forgot that it's not just that they have to map to something in the codomain. They can only map to, what is it? One and only one thing in the codomain, right? Because in this case, two is mapping to two things in the codomain, which breaks the rule. Okay, all right, so this is my answer. Intentionally incorrect. We'll see what ChatGPT has to say. It is definitely doing social buffering. Good start. No, it should have said wrong. Okay, because it really is wrong. It really should not have said good start because it's not a good start, not by my standard. Okay, but let's slow down and double check carefully. I like how it is very gentle and go like, okay, let's just kind of tap the brakes, okay, instead of going like just slam on the brakes and also pull the parking brake at the same time. Nope. Okay. So for f equals to 1, 2, 2, 3, 2, 4, which with domain 1, 2, the rule for a function is each element in the domain must map to exactly one element in the codomain. Okay, so even mentions, what it takes for a mapping to be a function. So now it says, okay, let's check element by element. One maps to two, it's all good. Two maps to three and two maps to four. Now we have a problem. So you can see how this is a tool that can really help you understand the concepts because when you get something wrong, it will actually tell you why you got it wrong or and also why and what is the correct answer and why it is the correct answer. So this means two maps to two different outputs, which violates the rule of there's only exactly one, and as a result, f is not a function. Note for your study guide, I mean, what else can you ask for from a tool that you only have to pay 20 bucks a month for? Okay. It even tells you what you need to put into your study guide. So you can say, tech doesn't give us the study guide. Well, guess what? ChatGPT will give you a study guide. A relation may associate an input with multiple outputs. That's just a relation. But a function is a stricter kind of relation, which is not how I would put it. Each input gets exactly one output. Okay, but that's GPT's own way of describing and relating relations with functions, which is not what I would do. I would definitely not try to mix those two. Are we good so far? Okay. So do you know how to use the tool? Yes. Okay. Very good. So on convocation day, I have, there's a video recording of me actually on the stage, part of the panel. Um, we had a panel that talks about, how to use AI in a college, setting, and I mentioned that I'm using GPT to implement mini-me's as a mini tax. Okay, if you're too young to have watched, the Austin Powers, movies, then you may not know what I'm referring to. But ChatGPT is my mini me. Okay, I'm trying to put everything that I know about the subject matter and how to approach the subject matter into the custom GPT. Hmm? I'm ready to retire. So if it can replace me like today, and my dean tells me, "Hey, Tack, we don't need you anymore. Why don't you go retire?" Go like, okay, thanks. Nope. So to me, it's not a problem. To someone like Ryan Hermley or Kakashan, yeah, they're still kind of at the beginning of their career, so it can potentially be a problem. But guess what? Somebody has to come up with this material to begin with. Okay, all the okay, you might be asking, so how does ChatGPT know about these things and use almost exactly the same wording that I use to explain these things? It's because I uploaded all the reading material that you are supposed to be reading to ChatGPT. So to anyone who's complaining, go like, Tag, the way you write is really confusing. Well, apparently it is not confusing ChatGPT at all. So that means, well, I mean, it's all here. And you can even, okay, this may sound insulting to some people, but that's not my intention. You can also say, I am not understanding. Can you explain this in, I'm going to use sixth grade language. There we go. We'll see. I mean, I haven't tried this before. I'm just giving it a shot here. Oh, input one to snack two. Okay. You you put in a button number, the machine gives you exactly one snack, which is the output. Oh, this is funny. I did not see that coming. It works. Hmm? It's not the worst. Hmm? But this is also what you can do with your other classes. Okay, now whether the other professors would encourage you to do this or not, that is up to the other professor. Okay, but if your professor is not objecting to using ChatGPT so that you can actually have a better tool to study the material, you can do this with just about any class. Now, what if the class uses proprietary textbook and whatnot? Well, your notes is still yours. Okay, so if you have your notes in the electronic form and you upload it to ChatGPT and go like, these are the notes that I'm taking in class, nobody can say you cannot do it. Yep. Oh, you can upload the full textbook? Oh, well, some textbooks may actually be quote unquote in ChatGPT already, because there are certain books that I'm supposed to read and kind of reflect on those books, and I don't want to buy the book, nor do I want to read those books. I just ask ChatGPT come up with a summary of the entire book, and it would do it. It's like, okay, I don't have to buy the book. It's not so much the money of buying the book. I don't want to spend the time to read the book. So you might be able to find resources that are not obvious, okay, in ChatGPT. All right. Any other questions related to what we are doing right now? No. Okay. So do you guys know how to practice for the exam? So some of you may be thinking, oh, I'll just copy and paste all the questions and slap it into ChatGPT. You can do that, But I have programmed this custom GPT not to give you a direct answer right away. So you might get frustrated if you were to do that. I actually tried it with all my classes in CISP 300. I gave my students a homework assignment today, and I tried it out. It's like copy and paste the assignment description and slap it into ChatGPT. ChatGPT said, "Okay, let me first check whether you understood these prerequisite concepts." So there's a whole bunch of questions I need to answer before it even tries to help me answer the question within the homework assignment itself. Yes. Hmm. Okay, if it's yes or no, it probably would do that, to answer whether it's correct or not. But for anything that requires any type of derivation or there are multiple steps to the whole thing, I think it will actually try to take you through the park. All right. So resource, right? This is a resource. So now we're gonna go back and I will give you guys a choice. Do you want me to go over exam one or do you want me to continue with the discussion of relations? If you want to spend some time with the questions on your own, just so they can test your own ability, before I give you the answers, then I will not talk about it because I think that's actually valuable. But if the whole class just goes like, just give us the answers, I can go ahead and give you the answers today. Okay, so we'll do it next Monday. Okay, cool. All right. So we are pretty much done, not entirely, but we are close to being done entirely with relations because what we have not really talked about yet is what GPT just mentioned. It's about partial ordering. So in order for a relation to be partially ordered, it has to be reflexive, antisymmetric, and transitive. Okay, which is exactly what we talked about earlier. So on top of this, we also have total ordering. So total ordering is the same as partial ordering, except it also has to be comparable. So the way we define whether a relation R is comparable over X is whether this quantified expression is true or not. Okay, so how do we read that? What does that mean? I'm pointing to the quantified expression here. Yep. Okay. All right. So, yep. So you're correct. The way you read it is correct, but how do we interpret it? In other words, let's work out some examples. Okay, so instead of me working out some examples and try to explain that, I will defer that to ChatGPT. So I'll say define X to be the set that has ABC in it, and I'll say define R to be the set of two tuples where we have AB, okay, as a two tuple, BC as a two tuple, and also AC as a two tuple. And that's the entire set. Okay, so we close this. And then I'll ask, is R comparable as a relation over X? Okay, that's my question. What do you think? Okay, so let me do this. Okay, so let me do this. Okay, give me a second here, because what I want to do is I want to show the quantified expression when we can also see the relation versus R. So there we go. Keep this one always on top, and then switch back to what I'm about to ask, ChatGPT. So the backslash before the brace is necessary because braces have special meaning in LaTeX. So I have to escape the use of the braces. So that's why whenever I need to use the actual brace, I need to put a backslash to escape it. So don't let it distract you. Okay. So now the question is, do you think this R is comparable or not? In other words, Is the quantified expression always true regardless of how you choose the elements E and F from X? And this is a tricky one. You have been warned. Okay. All right. All right. So why is it not? You're correct. It is not comparable. But why is it not comparable? But that would still work, right? If E is A, F is B, then A R B is true, and this is an OR. So if one side of the OR is true, the whole thing is true. So that one is not the okay. Okay, does this say anything about E and F cannot be the same? It does not. The only requirement is E has to be an element of X, F has to be an element of X. What if both of them are A? Okay, so think about this. Okay, E is A, so is F. ARA is false. ARA is also false. False or false is false. I have just found a case where what needs to be true is actually false. That is why it is not comparable. Is that okay? So this is my interpretation and my explanation. So now we press the enter key and we are testing ChatGPT to see whether it will give you a reasonable explanation of why this R is not comparable. Okay. In other words, I'm not only showing you what the tool can do, we are also testing what the tool can do. To what extent does it work in this class? All right. So we'll go ahead and just press the enter key like that. Mhm. Yes, I have just evaporated a few bottles of water. But all right, good question. You're asking whether RR is comparable. Let's unpack carefully. We call comparable in the context of relation. A relation can be checked for partial order, impartial order, blah blah blah. So comparable is the only additional requirement for a relation to be totally ordered as opposed to partially ordered. So now we look at this part here and they go like, okay, let's check. Is it reflexive? Okay, so transitive, yes. Symmetric, no. Reflexive, no. But I'm not even concerned about whether it's totally ordered or not. So we have to kind of skip all the way to step three, whether it is comparable or not. Between A and B, it is comparable. Between B and C, it's comparable. Between A and C, it's comparable. Every pair of distinct element is comparable in one direction. But since reflexivity is missing, it is not a partial order. Okay, so ChatGPT is wrong in this case. At least so far, the relation is not partially ordered. I did not even ask for that. Okay. However, in terms of comparability of elements, it this is wrong. So ChatGPT is actually wrong in this case. Hmm? Yeah, yeah, it's the same chat. Oh, we are well within the context window. The context window of GPT-5 is somewhere around 200,000 tokens. We are nowhere close to that limit. Okay, okay. So let me answer his question in the meantime. Go ahead. No. Okay. Okay, let me just kind of interrupt you for the time being. The way we define partially ordered is it has to be reflexive, anti-symmetric, and transitive. So that's how we define partially ordered. Does that help? Okay. It also has to be comparable. Yes. So comparable is the additional property for a relation in order to be totally ordered. So you can have something that's partially ordered, but if it is not comparable, then that's all it is, which is partially ordered. If you want something that is totally ordered, then you also need comparable. Correct. But you can also look at comparable outside of the context of whether something is partially ordered versus totally ordered, and that's what I'm asking. And that is what confused ChatGPT because there are very few places where people ask about comparable, but outside of the context of totally ordered or not. So let's go ahead and read the entire output. Okay. Would you like to reframe this as is every pair of element comparable? Okay. So I'm going to tell GPT about what about this, right? Okay. So let's go ahead and do that. So in terms of whether this R is comparable, what happens when E equals to, what was it? Okay. So both of them being A. E is A and F equals to A. Okay, there we go. So we'll see. Great focus. You're zooming in on the subtle case of self-comparisons. What comparability means. In a relation R on the set X, two elements EF in R are comparable if, okay, this is not good. It's not either, okay, because either or implies exclusive or. We are not using an exclusive or, we are just using a regular or. In every pair, da 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 da, in the case, so A is not comparable to itself under R because the reflexive pair AA is missing. Why this matter? Because the R is not reflexive. Answer is so A is not comparable to itself. Okay, so it's evading the question of whether R is comparable or not. Go ahead. So are you referring to here? Oh, you mean here? Yes, so ERF is the same thing as EF in parentheses is an element of R. Yeah, it's just a shorthand of that. Yep. All right. So ChatGPT has been evading the question. So now I have to ask it directly. Okay, so I'm going to say, so can you answer directly whether R is comparable? Okay, so I'm forcing the hand of ChatGPT. Okay, so the relation R in this case is not comparable as a relation over X in the sense of a total order, blah 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 blah. Okay, and then I can then confuse your ChatGPT even more and ask, so why did you say that R is comparable before? Oh, this is good. This is good. You are right to push me on this. So it noticed that I'm being a little bit pushy, a little bit of a nitpicker in this case. Let's clear it up, blah blah blah. Okay, but it looked comparable because of all the distinct elements. So it noticed what mistake it made because it is only looking at distinct elements of EF. It forgot that E and F can be the same. So I think this is a really kind of useful exercise, okay, because it illustrates how far the tool can work for you, but it also illustrates sometimes it is not entirely right. So yeah, go ahead. Say that one more time. So if I ask the question, I'll be using the definition that is in the reading material. So it would be based on this particular definition. Yep. So according to ChatGPT, because it used the word exclusive or, so that means if A, B, and BA are both in the relation, it would also not be considered to be a comparable relation. So let's check that, okay? Because okay, so let's do that, okay? So let us take a look at another example. Okay, so X is still the same, which is A, B, and C. And this time I fix the other one. So I would say R is, so now we have all the self-referencing. Okay, so we have AA, we have BB, okay. We also have CC, but this time I also have AB, AC, BC, which is the minimum that I need in order for R to be comparable. But I'm going to put in CB2, okay, because now the idea is to test whether ChatGPT still thinks that BC is exclusive ORed with CB or whether it is a regular OR. What is the difference? What is the difference of exclusive OR versus a regular OR? That is correct. Okay. So if ChatGPT still has the misunderstanding that this is not an OR and it is an exclusive OR, then it would call this one not comparable. So we are now going to test it. Okay. And we'll say, can you tell me whether R is comparable over X? Now, if you are pushing ChatGPT like this, you are studying, okay? Because you're looking at the very fine points of the definitions and you're going like, okay, let's check whether ChatGPT can actually differentiate between those cases or not. So this is another way of studying is to challenge and see if you can trick ChatGPT to give you the wrong answer. Apparently, this is a difficult question. Oh, there goes those gallons of water. Ooh, this is good. Hmm? No, I don't want to skip. I wanted to keep boiling water. Where's my coffee? I need hot water. Great example. Quick recall. Blah 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 blah. Okay. No, the actual using takes a lot of electricity too. It depends on the model. They never really quite release the specifications of GPT-5, so we don't know the number of parameters that are used. The estimate is it has half a trillion of parameters. So that makes it a huge model compared to even 4.0. So just because of the number of parameters, that makes it kind of energy hungry already. Okay, so it says R is comparable over X. Okay, so it fixed itself because it used to say exclusive OR, but this time it went back to the regular OR. So I couldn't quite trick it, but I can push it a little bit more. Okay, because I can now say, but you mentioned, but you used exclusive or, oh, I cannot spell, exclusive or instead of or before. Which one is correct? Now, I didn't quite provide the full context, but we'll see whether ChatGPT can pick up what context I'm using to refer to exclusive or versus or. Uh-huh. You know how people have like a body count when they're watching your John Wick? So when I'm teaching my classes, we should have a gallon count. Water gone like that. Okay, so good question. This is where precision really matters. Do you guys have a general sense or feel that precision is important in this class? Yeah, maybe. It's we're okay with being vague. No. All right. So it says for comparability in the relation, the correct logic is or, not exclusive or. So it was actually able to figure out that it was kind of wrong to begin with. It used the wrong operator. But now it understands, okay, yep, after thinking, after evaporating some gallons of water, I now realize that the regular or is the correct answer. But can you see how you can have a conversation like this with the material instead of just reading the material? And this can help you understand the material a little bit better because of the interaction. You're not just reading something, you're actually going like, okay, let me push you. Let me see if I can confuse you. Let me see if I can give you the wrong answer and have you to tell me it is the right answer. So you have to think about all those tricky cases. The thinking of the tricky case is one of the best way to study because you're pushing the envelope of the definitions. You're looking at all the edge cases, all the boundary cases, and you're looking at the very border right between what is and what is not. Yep. hmm Okay, which assignment are we referring to? All of them? Well, one thing you can do is to copy and paste the example into ChatGPT and say, ask me some additional questions in this style. hmm Okay, so I'm guessing you're referring to the function, the surjection, bijection stuff. Well, the assignment is a way for you to confirm your understanding. It was never meant to be a practice. Okay, so how do you practice? This is how you practice. You use ChatGPT to help create test cases, and then you have an infinite amount of test cases you can generate. Well, I shouldn't say infinite, but you have a lot. Yep. Mm, I'm not quite getting the point. Mm, okay, so what is the point? Would I recommend using concrete examples instead of reading the material? Okay, so it depends on how you use ChatGPT. Um, the way I would study, which does not mean it's the right way for everybody, but the way I would study is I would understand the quantified expression, all the definitions, so that I have a solid foundation of how things are supposed to work. And then I would only use ChatGPT to generate some examples so that I can try to answer those questions to confirm my understanding. Okay. So there are two ways to look at homework assignments or exercises. Okay. Some people learn by rules, like myself. Okay, I learn by rules. The exercises or the homework assignment or the way I use ChatGPT is only here to confirm my understanding. Okay, because if I got it wrong, then I go like, oh, okay, I must have misunderstood something. I have to find out what I misunderstood. The other way to learn is to learn by example. Okay, so give me examples of relations that are transitive. Okay, and give me examples that are not transitive. And then you're trying to figure out the pattern yourself and not referring to the definitions of what is transitive. So that's the other way to learn material. The learn by example method is what most people use. Okay, I found that out myself that most people learn by example. There's a problem with that approach. Okay, so what is the problem with learning by example? You're looking at all the examples. Okay, these are transitive, these are not transitive, these are reflexive, these are not reflexive, and you're trying to kind of learn the pattern. Okay, of what is transitive and what is reflexive and what is antisymmetric and so on. What is the problem of that approach? If you go down, or the examples might have you might have some examples missing from your training samples that is important to illustrate certain cases of what is and what is not. Okay. Yep. Exactly. Yep. So I personally do not learn by example. I would look at the definition and sometimes I would have to spend a lot of time too to understand some of the more abstract stuff, but I would spend the time, okay, and when I'm studying, most people would go like, "Oh, tech is goofing off." Because when I'm studying, it's all up here. I'm not even reading, I'm not writing. It's all just me trying to absorb the material. Usually it is just a quote unquote simple concept that I'm really just trying to clarify. So there's no output whatsoever. So when I study, my classmates back in high school and also college would think that I'm goofing off because I would just be laying down or eating something when everybody else is like having stacks of books and busy writing and reading stuff. I won't be doing any of those. But because I'm trying to absorb the material, I'm trying to get to the core of what it means to be transitive. What is the core of what it means to be reflexive and so on. So I'm not saying one way is the correct way and the other one is not correct, but I'm saying that in computer science, okay, learning by example may not be the best method. Okay, you can start with that, okay, but at some point you have to be picky about what you're understanding, and you start to ask for cases where, okay, but the example doesn't quite tell me whether this is transitive or not. So now you have to think about that using the definition of what exactly transitive is. Is that okay? Okay. Yep. So I was also accused in on convocation by somebody who is opposing the use of AI that I am doing this to save myself time so that I don't have to do my job in teaching. But that's not what I'm doing, okay? Because I'm free before this class, and you guys are more than welcome to knock on the glass door to talk to me before this class or after this class, okay? So I'm on campus 5 days a week. So if you come to my office hour and you come with a question like, okay, this is what I asked your ChatGPT, it gave me this answer, but that seems to be wrong. Can you tell me one way or the other whether ChatGPT is wrong in this case? I'll be more than happy to talk to you, okay, to have a discussion and stuff like that. So this is really just a tool so that people do not call me on my cell phone number 2 a.m. in the morning on a Saturday, okay? So if you have questions at 2 a.m. on the Saturday morning, don't call me. Use this. On the other hand, if you have a question like this on a regular day, like on a Wednesday, at about 3 p.m., stop by my office. I'll be more than happy to clarify these concepts. Okay? We good? All right. So, is this session useful? I mean, does it kind of help demonstrate what you can do with ChatGPT in a in I think it's in a productive way? Yes. Okay. Now, there are other ways to use ChatGPT too. This is something that may not have tried, in this context, so we'll give it a try. So we'll go ahead and say the way my professor writes is very difficult to understand. Can you pro okay, okay, bad grammar here. Okay, so Grammarly is fixing that. So I'm now saying, can you um, produce a version of the reading material that has many examples and easier to understand. Um, Create a PDF on relations and give me a link to download. Okay, so we'll see. In other words, I'm using ChatGPT, I'm testing to see whether ChatGPT can act as a transmission, like car transmission, and many more gallons of water is evaporating. All right. So this is a simplified PDF guide on relations with clear definitions and lots of examples. So we'll see. I'm curious. I don't know about you, but I'm curious. It's like, come on, tell me. All right. So this is a quick summary. What is a relation? A relation is just a set of ordered pairs from a set X. That's awfully vague. I would say, a relation is a subset of R Cartesian product with R, but this is a really easy way to look at it, but it's not the way I would define it. Reflexive relation is reflexive if every element relate to itself. That is correct. Um, okay, so it's avoiding the use of mathematical notations whenever it can. Symmetry is if xy is in R, then yx must also be in R. Okay, but this one does not easily explain why the empty relation is also symmetric. Okay, it is implied, but it doesn't quite directly relate to that. So I don't know. Do you think this is a good summary, or do you think the original definitions are better? Well, now you have the option to crank it up or kind of crank it down any way you want. All right. But what do you guys think? You have your opinion. What about the rest of the class? Exactly. It is not specific enough. So you can crank the dial, right? You can go back to ChatGPT and say, okay, what you just gave me is great for examples, but it is not specific enough. Okay, so you can say, okay, can you add more specific descriptions of what each property is about. So you can basically have a conversation and adjust the setting until you go like, okay, this is exactly the right number of examples versus the specific definitions. So I hope you guys do not feel that I'm pushing the responsibility of a professor to you. I'm really just trying to give you tools and options to go about studying. But from my past classes, I understand that many people do not like options because whenever I go like, well, there are three ways to do this, and this, the almost for sure somebody's gonna ask, so which way is the right way? And I go like, they're all right, they're all correct, they all work, but which way is the best way? It's hard for me to say which one is best because it kind of depends. Which way is the way that you would use? I go like, well, They all work. Okay, it depends on which way you prefer. Okay, because I don't think the same way that you do, and you do not think the same way that I do. So it's all about options. Okay, and I think being having more options is usually better. You have to evaluate which option works best for you. That is something that you can answer that I cannot answer. So are we good so far with this? Now, does this use of ChatGPT, is it consistent with how your other professors look at AI or GPTs or LLMs? Okay, I see a lot of people shaking their head. So what is their policy? What is the consensus of your other professors? You don't refer to it by name even. It's like, oh, that tool that starts with A, right? I see. No AI use. Hmm. Well, I don't think I want you guys to use AI in the assessment, in the exams, but when you're studying, I think this is a tool. Okay. Now, for those of you who think, okay, I don't need this tool, I can read the material just fine. I don't need the tool, don't use it. Okay. It is just something that is available. But if you think, oh, okay, being able to interact with the material, being able to ask for more examples and more exercises to practice on, if you think that is useful, it is here. All right. So I think that's the end of today's lecture. Next Monday, we'll talk about the practice exam. So you can use the AI tool to try to help you with the exam to study and also at least to understand what material relates to those questions. But personally, I would try to do it without any help, just by reading the material and your own notes. And if you're stuck, then you can go ahead and either ask me or ask the tool to give you some pointers. All right. So I'll see most of you next Monday, and some of you I will see probably tomorrow if you're on in my 310 class. Cool.